So, yes, welcome students. We will continue the module number 3, and today I will try to wind up quickly this module 3. Okay, because we have midterm examination from the next week. Okay, so in today's discussion, we will continue our discussion as I told on extrusion-based additive manufacturing process, which is the major topic in the case of module 3. Okay, so in the previous class, we could see that we could understand the basic methodology about additive manufacturing process, that is extrusion-based additive manufacturing process. Okay, and out of these extrusion-based additive manufacturing process, which are also commonly known as fused deposition modeling. Okay, uh, in this process, the material is extruded through a nozzle. Okay, and it is deposited on the build platform or on the previously created layer. Okay, so this we have discussed loading principle, types of how liquefaction takes place, how extrusion is done, and how the solidification takes place of your printed layer. Okay, then positional control and the bonding of energy required to uh, for the bonding of material, that is the material which is being printed as well as the previously printed material or the support material. Okay, so in today's discussion we will continue the same, and here we can see a typical schematic of your FDM printer, and you can see different part like this is your extrusion head, this is your part that is being printed, this is corresponding to your support material, the support material that has been printed. Okay, then this is your build platform, which is lowered once upon uh, one layer is printed. Okay, or it is lowered by the height equal to your layer thickness. Then in the extrusion head, you can see some wire kind of arrangement is coming. So these are not actually wire. These are actually these are actually not wire cables, which I meant to say. It is your either your support material or the part filament through which your material through which your product is supposed to be printed. Okay, so we will try to see how this print head, how the printing takes place in the case of extrusion based additive manufacturing process. Okay, so in the case of extrusion based or FDM printer, what we are having, a spool of thermoplastic filament is first loaded onto the printer. Once the nozzle has reached the desired temperature, the filament is fed to the extrusion head and in the nozzle where it melts. Okay, so this process we have discussed in the previous lecture too, that we have thermoplastic filament in the form of very thin wires. Okay, thin filament. Okay, and it comes in the form of spools. Okay, uh, the figure if you remember in the previous slides. Okay, so it comes in the spool as well as in multiple color. You can get these filament in any color of your desired requirement. Okay, as per your requirement. Okay, so once this filament is loaded into your printer, it is fed into your extrusion head, where it gets melted, and then extrusion takes place through the extrusion head. Okay, So this is how the extrusion head works, and the material is deposited on the build platform. The extrusion head is attached to a three-axis system that allow it to move in the X, Y, and Z direction. The melted material is extruded in thin strands and is deposited layer by layer in the predetermined location, where it cools and solidifies. Sometimes the cooling of the material is accelerated through the use of cooling fans attached on the extrusion head. So, if you want to accelerate the cooling locally of your printed material, some cooling fans may be attached to your extrusion head. To fill an area, multiple passes are required, similar to coloring a rectangle with a marker. When a layer is finished, the build platform moves down, uh, or in other machine setup, the extrusion head moves up. Okay, so the setup may be like nowadays. The arrangement are like that. Instead of lowering your build platform, you may have arrangement that you are moving up your extrusion head. Okay, so the ultimate aim is to print the another layer as soon as the first layer is deposited, or the layer creation is completed. Okay, so this process is repeated until the part is completed. Okay, so this is how your FDM printer works. Then coming to the nozzle design, because uh, ultimately, since the material is coming through your nozzle, so the flow rate it needs to be controlled very accurately. Okay, very precisely. Okay, the material, as I told in the first lecture, that the material flow rate should be exactly equal to the nozzle speed. Okay, the movement of your nozzle on the build platform or on the previously printed layer. Okay, so the how this flow rate is controlled, we will see. We can see here there are few simple arrangement for the nozzle. Here we are having a screw, which is driven by a control motor. So here you are having a control motor. Then this is your hooper. Okay, this larger portion is hooper. This lead screw arrangement, this screw arrangement is called your auger. Then uh, you have scraper. Then this small part, it is called your barrel. Then this is your nozzle tip. Okay, so which is basically responsible to decide the diameter or the shape and size of your extruded material. Okay, so yeah, so these are a few arrangement related to your nozzle, and the ultimate aim is that the material should come out of your nozzle tip. Okay, yeah. There are some more arrangement you can see here, actual diagrams. Yeah. So once you extrude the material, it comes in the form of rods. Okay, so how these material are printed on the build platform or on the previously printed layer. You can see here a few samples. Uh, just I have taken for example in order to make you more clear how the material is extruded in additive manufacturing processes, how it is deposited on the build platform or on the previously printed layer. Okay, so like this is one reference is given from where I have taken these figures. Okay, so these are A and D are corresponding to the diameter, nozzle diameter 10 mm, Then B and E are corresponding to your 15 mm. So these are corresponding to 10 mm, these upper and lower figure. Then B and E are corresponding to 15 mm nozzle. Then C and F, these are corresponding to 20 millimeter nozzle diameter. Okay, so we can see here it is important, the nozzle diameter is a important parameter because ultimately it is going to decide the shape and size, or the quality of your product which is printed through your uh, FDM printer. Okay, yeah. Yes. So here you could see how layer by layer was deposition was taking place. Now we will move to the issues, major issues which comes when we print the material, or we print the component using your FDM printer. So the main issue is the warping effect. Okay, so why this warping takes place, we will discuss here. Okay, so the choice of designer can also reduce the probability of warping. Large flat areas, think of a rectangular box, are more prone to the warping and should be avoided when possible. Thin protruding features, think of prongs of a fork, are also prone to warping. In this case, warping can be avoided by adding some sacrificial material at the edge of thin feature. For example, a 200 microns thick rectangle to increase the area that touches the build platform. Okay, so here you can see, since this material, suppose this layer has been yeah, we will continue. Let us continue first. Sharp corners are warping more often than rounded shape. So adding fillet to your design is a good practice. Okay, so fillet needs to be added in the sharp corner. Different materials are more susceptible to warping. ABS is generally more sensitive to warping compared to PLA or PETG due to its higher glass transition temperature and relative high coefficient of thermal expansion. Okay, so here you can see what is warping actually. What is happening, suppose once you have printed you are trying to print a new layer on either on previously printed layer or on your build platform. What is happening, the material is the newly deposited layer cools. If once it is cools, what will happen, it will sink slightly. Okay, and due to due to shrinkage of this particular layer, what will happen, it will pull the underlying layer upward, resulting in warping. So you can see this is the warping effect. Okay, and if this effect continues, it will land up to a and instead of uniform printing of component, it will end up to something like this. Okay, so here in the right hand side you can see the actual effect of your warping on the overall geometry of the printed component. Okay, so yeah, then the this warping can be can be reduced to a extent by proper adhesion as well as a smaller cooling rate. Okay, instead of high cooling rate, we can adopt a smaller, less cooling rate. Then this warping effect is reduced. Okay, so we will discuss in this here about the layer adhesion, how the layer adhesion takes place between these during the printing of material using your FDM printer. Okay, so the good adhesion between the deposited layer is very important for an FDM part. Okay, when the molten thermoplastic is extruded through the nozzle, it is pressed against the previous layer. The high temperature and pressure remelts the surface of the previous layer and enable the bonding of new layer with the previously printed parts. Okay, so this is basically the layer addition. That if you have applied uh, sufficient energy to your layer, and your your uh, your uh, your layer which is being printed, it is getting adhered with the previously printed layer. So obviously this will remelt your previously printed layer by a certain extent. Okay, so some remelting takes place on the previously printed layer, so that the proper bonding takes place between these two layers, and this continues with till the creation of your final product. Okay, yeah. Okay, so uh, this was all about your FDM printer. Then now we will continue with the material part. That what are the different materials that can be printed, that can be used for 3D printing in extrusion-based additive manufacturing process or additive FDM machine. Okay, so these are general type of machine. I will read one by one about these materials and their uh, description. Okay. So ABS, yes, these are the different categories of ABS. Here you can see their benefits and applications. So I will not be reading. I will be sharing this PPT with all of you. And if you are having any query, we will discuss in the interaction session which I am supposed to conduct today. Okay. So if there are any query, we will discuss in the interaction session. Okay. So I will share this PPT with all of you. You go through these different materials and their description, their benefits or advantages, and their application areas. Okay, so yeah, there are multiple material, thermoplastic material, which are used. Wide variety of materials are available for use in FDM printer. Then coming to the application part. So yes, before coming to the application part, yes, go through these materials and their advantages and their application areas very carefully. Okay, the coming to the application part of the part which are produced, which can be produced using your FDM. uh, these are used in a concept of or design visualization. Suppose you have some concept, you have some idea which you want to visualize immediately before going to mass production. You can go to the FDM process. Direct use component, the materials the component which is used, which is printed using your FDM, it can be used directly. Then investment casting, it is widely used. It has medical application too. Flexible component can be easily printed using your FDM printer. The advantages, yeah, there are a lot of advantages we could see in the material section, but there are few specific that are mentioned here, like strength and temperature capabilities of your build material, safer safe laser free operation, easy post processing of your printed part. Then obviously there are some disadvantages too, like process is slower than laser-based system. Build speed is low. Thin vertical column prove difficult to build with FDM. Thin vertical column cannot are quite difficult. Physical contact with the extrusion can sometimes topple or at least shift thin vertical wall and columns. Yeah, these were the disadvantages. And so here we will end the module 3, which is the extrusion based additive manufacturing process. Okay, I expect that all of you will go through the, specifically with the material part of your PM process or extrusion based additive manufacturing process. So